Okay, this video we're going to talk about how to factor a number. Now that number we're going to call it completely factored, which means we've factored it down to its prime factors. What prime numbers make up 60, 24, 13, and 75. So the first method that I'm going to show you is called the tree method. Most of you should be familiar with that. We're basically going to make a tree of the prime factors. So the first thing I'm going to do is we're going to work on the 60. I have to ask myself, okay, a prime number is any number that its only factors are 1 and itself. So 6 would not be a prime number because it could be 1 and 6 and 2 and 3. Those are the 4 possible factors. So when I look at it though, I'm going to break down 60 to be 2 numbers. I'm done with factoring it when I have all the factors laid out. Those factors multiply to give me 60, and every one of those factors is a prime number. So as I said, the first numbers I think of are 6 and 10. You might have thought of 12 and 5. That would work too. So 6 and 5. So now my question is, first of all, does this equal 60? And 6 times 10 equals 60. When I get done, everything I lay across of those factors should equal 60. Well, 6 is not prime, so I'm going to break 6 down to be 2 times 3. And 10 is not prime, and I break 10 down to be 2 times 5. Now 2 is prime because the only factors for it are 1 and 2. 3 is prime, only factors for it are 1 and 3. And 5 is prime, the only factors for it is 1 and 5. Now if I look, 2 times 3 is 6, times 2 is 12, times 5 is 60. So not only have I broken it down, but when I multiply across, it equals my original number. So I'm done. Now what I have to do is I have to be able to list these in numeric order from smallest to greatest. So what I'm going to do with that is I say, well, I have a 2 here, and I have a 2 times the 3 times the 5. So this equals 60 because 2 times 2 is 4, times 3 is 12, times 5 is 60. So this is called my expanded form. And the exponential form of this is 2 to the second, because I have 2 factors of 2, times 3 times 5. Okay, so that number's done. So let's move on to 24. So if we look at number 24, again, we're going to ask ourselves, what 2 numbers multiply together to give me 24? Now the first ones I think of are 12 and 2. So 12 times 2, and that equals 24. Now the thing I'm suspecting you probably haven't seen before is this part here where you're multiplying it to make sure that it equals that number. That's just how you check to make sure you've done it right. I know a lot of you've left like little dangling limbs off. I'm going to tell you, I want you to break it down. So if I look at this, I want it always to come out to be equal the number that we have. So when I look at 12, 12 is not prime. So 12 could break down to 3 times 4. So when I look at the 2 is prime. So I'm just going to bring it down. And when I check, 3 times 4 is 12, times 2 is 24. Now when I look, 3 is prime. So I can keep 3 here. 4 is not prime, but I could break it down to 2 times 2. And then I just keep the 2 coming down. And when I check these, again, I have 3 times 2, which is 6, times 2 is 12, times 2 is 24. Again, I have to put them, when I write out my expanded form, I have to write them out in numeric order. So 2 comes before 3. So quite simply, this is going to be 2 times 2 times 2 times the 3. This is the expanded form. And when I check that, it's 2 times 2 is 4, times 2 is 8, times 3 is, 8 times 3 is 24. So this checks to be 24. So again, these two versions, this is the expanded form. And then when I write it in exponential form, I can see that I have 1, 2, 3 factors of 2. So 2 is the base, and the 3 represents how many factors I have of that number. So this is 2 to the third times 3, and this is the exponential form of that number. So 24 in expanded form would be 2 times 2 times 2 times 3, which is useful when we're talking about fractions, when we're going to factor out polynomials. Anytime we do factoring, it's going to be valuable to know that expanded form. And later I'm going to give you an assignment to do a hundreds chart, and you'll need to have these. So I would write these down and keep them written down so that you have these as resources. It's going to help fractions be easier. It's going to help factoring be easier. And I would hold on to this for the next couple of years. It's going to be a very valuable resource for you. So the next number we're going to look at is 13. We look at 13 and, well, 13 is prime. There's nothing more we can do with it. 13 is 1 times 13. We're done. We can't do any more to it. So the next number is going to be the 75. When we look at 75, first thing I want to do is look and say, well, 75, what two numbers can I multiply together to give me 75? And some people will write 1 times 75. Well, that's fine, but it didn't get you anywhere. So we want to know two prime numbers. 1 is not a prime number because 1 is only itself. So it's called a unique number. It is not considered a prime number. So what two prime numbers? Well, when I look at this, I see the 5. So that means this has to have 5 as a factor. And if I go down the 5 column on my multiplication table, I can see that 5 times 15 equals 75. So your multiplication table is a really good friend as you're doing this, because you can break it up, look for 60, look for 24, if you look at 13, you know it's a prime number because it's there by itself on that row, and the only way to get it is 1 times 13. For 75, I can find it here. I can find it 3 times 25. Any one of those two would have worked. Now when I look, I know that 5 is prime, so I'm done with that part. But now what I have to do is break up the 15. And the 15, well, I look and I can see that's going to be 3 times 5. And what you're going to notice is this part right here that I carry it down, that's different than probably what most of you have been taught. But what it does is it provides a safety net. You don't ever lose that number. And you always check. 5 times 3 is 15, times 5 is 75. This equals 75. So again, I've got to write it out in an expanded form. So I'm going to write that out and say, well, the smallest number is 3 times the 5 times the other 5. This is my expanded form. And then as I look at that, I check 3 times 5 is 15, times 5 is 75. I could look at it and say, well, 5 times 5 is 25, times 3 is 75. If you have 3/4, it's 75 cents. So this equals, and then I'm going to put the exponential form, which would be, I only have one factor of 3, but I have 5 to the second, so times 5 to the second. And again, you're going to do a hundreds chart where you're going to want these numbers written out. So that's how you do the tree method. You can use this, or you can use the cake method, which I'll show you next. So this one, I'll save this video, download it onto Canvas so you can see it, so you can watch that over and over again. Try this with some other numbers. You're going to get a homework assignment that I'm going to go over these numbers with you on Tuesday and Wednesday. And so you'll have a chance to play with this, factor it out, use this method, use the cake method, and we'll see how it goes. Okay. See you later, guys. Again, let me know how this works. If you're struggling with it, let me know. The way for us to learn together is to communicate. If you're having a hard time pulling it off of Canvas, you just got to let me know, and we'll go from there. If you're struggling with something, the way I'm saying something, if I have a repeated word that's just messing with you, let me know. If there's something I'm saying in here that's confusing, let me know. Send me an email. You guys have been really good at communicating, so let me know. I want to make this a valuable tool for you, for anybody else that sees it. Okay, thanks a lot. Have a good day.